On va démarrer. Oui. Ok. Bonjour, je suis très content d'avoir une salle pas mal pleine quand même avec seulement 2 jours de préavis. On voit que CentrEau fonctionne. Bienvenue à tout le monde à distance. J'espère que vous comprenez bien ce qui se passe ici. I'll switch to English because even though Peter Krebs is from Switzerland and therefore had to learn French, his French skills are not that good to have a communication, so we'll have a presentation in English. So Peter Krebs is a good friend of mine, to say first thing. I invited him for a PhD defense of Julia Ledergerber, that's here, yesterday, and then we have the habit to ask the person that comes to also give something wider perspective for something that might be interesting for CentrEau. That's what's happening today with Peter Krebs. You've seen the topic. He will explain much better than I do what it's about, but I'm going to say something about Peter himself. He's Swiss, as I said. He studied at ETH, which some of you may know is like one of the top universities in the world. I think you said it's like the first one outside of North America in the ranking, the Shanghai ranking. But not at the time he was studying there, he says. He studied his PhD there in fluid mechanics of wastewater treatment. That's where we got to know each other. And then since 1998, he moved to Dresden, University of Technology, and became the director of the institute. That's how a professor is, Hochlehrer is in Germany. They become head of an institute, in this case, urban water management. Not
everybody.
No, that's true. No. So that's University in Dresden. Dresden is Western Germany, full development, and a very nice city if you can visit it. Don't forget. What is also important, I think, for CentrEau is that he's a founding chairman of the German Water Science Alliance, and which initiates very similar things to what we try to do with CentrEau, interaction of all water-related disciplines, and dealing with strategic developments in water research. His main interests is to deal with coupled water systems. So look, that's why we have him here today, because he's talking from the tap to the river and everything in between, and how micropollutants evolve. I will not go into the details of this. I think you want to present something about. So he's going to talk about the Center for Advanced Water Research, which is in Dresden, which is also the co-founder or the co-director at the time being. So first some words on that, and then the talk about micropollutants and the work. Peter, you have the floor.
Okay.
So we have a presentation, and we'll have time for questions.
Okay. Thank you very much, Peter. Bonjour, mesdames et messieurs. But I will switch to English. I understand quite some French because I'm Swiss, and in school we learned French, and I was fluent 40 years ago, but I never really practiced and used it. And this is a pity, but however, it's how it is. So I'm really glad to be here. Embarrassingly, it's my first time in Quebec, although we were old friends and we reconstructed that we know each other since '93. And well, I'm in Dresden for more than 20 years. You are here for more than 10 years. So time is proceeding, but however, we still recognize each other and we see each other. Peter asked me to tell just a few words about our Center of Advanced Water Research and about our university, and he was already laughing a bit about the information we get here on the official homepage of TU Dresden that is providing very exact numbers and for which semesters it counts. So we were on 32,000 students in the beginning of the winter term 17-18. In the meanwhile, it has stabilized a little higher. So we are kind of varying between 32 and 37,000 students. It's a T for a technical, but however, it's not so technical anymore. The university became a full university over the years and decades. So we also have law, economics, philosophy, languages, and subjects like this. 120 study courses all over university, so that is an indicator for the diversity within university. More than 8,000 employees all over, including administrative employees. But when you look at how many people are funded directly by the state, these are a bit more than half, and almost 4,000 PhD students and scientists are funded by third party. So this is the budget, so €500 million is the all over budget, of which about half is actually acquired on the research foundation market. Now I'm experiencing the troubles. Julia had yesterday, it takes a little while until the slide is changing after you press the button. This is our department. I don't want to go into detail. It's just the fact that in our Faculty of Environmental Sciences, we have a department on hydrosciences, and this is reflected not only in research and research cooperation, but it's also reflected in our study courses. So we are a department and we offer study courses on water issues, on hydrosciences, including all the water-related disciplines from natural science to engineering disciplines. And these disciplines you see from the title of the institutes that are part of the department: hydrochemistry, biology, meteorology, waste management and circular economy, groundwater management, urban water management. If you go to a normal or any other German university, you would find these institutes distributed to approximately 5 different faculties. And we're quite proud of it. And then we also have kind of joint appointments of some professors together with UFZ. That's a German abbreviation. It is for the Helmholtz Center for Environment Research. There are some huge university external research institutions in Germany, and Helmholtz is the largest one. They are also have very diverse topics, but this one is on environmental research, located in Leipzig, only some 100 kilometers away. So actually 100 kilometers, not several hundred kilometers. So what's this Center for Advanced Water Research? It's actually a joint initiative of the water sectors of TU Dresden and UFZ. And we are approximately, with a conservative counting, of approximately 300 scientists active on water research, joining our capacities. If you look at the official publications, they are writing about more than 500 people, especially UFZ. But when you sum up all these people active in water, soil, ecology, and so on from UFZ, you will get many more people than what they have. So they sell them twice and 3 times. So I try to be quite conservative and looking at the ones really with their core power being active on water research. These are the competence fields. It's water quality, water quantity, urban water has a special role, but also society and climate under change, global change with a much broader picture than just on climate change. We also have a water governance section, and then a cross-cutting field of knowledge, data and information processing. So much for the moment. It's just as an appetizer. So I know CentrEau is larger than this. You are talking about much higher numbers, but we are actually able to cover the entire water cycle, also through the atmosphere, through the groundwater, hydrogeology, and all these things. So we might be a partner to discuss with. So this is the topic you were invited for. I was announcing pharmaceuticals in the water system. We had 2-3 projects in the last years. I'm mostly going to report about one project to show you the pathway of the pharmaceuticals from the production, where we do not really kind of model the production, but we take into consideration when we look at measures the production of the pharmaceuticals all the way through the people, through the water, wastewater system, into the surface waters at the end. So that's the pathway I was just announcing. So we have the development and the production of pharmaceuticals. Pharmaceuticals are prescribed by medical doctors. It is consumed by the patients. Then they excrete it. Afterwards, after excretion, it's finding its way into the sewer system where it's transported and potentially transformed. Then we have elimination and transformation in the wastewater treatment plant. I hope all of you are familiar with this abbreviation, WWTP, but I learned WRF is used here. That's WRRF. Yeah. Okay. So we have a bypass here. Now that's the first bypass from the consumer directly into the sewer, and that's non-target disposal. People do not consume the medicine, and it is over the date, has exceeded the date of activity, and they dispose it either in the solid waste or through the toilet, especially liquid pharmaceuticals. They obviously quite often dispose directly into the toilet because people want to collect the glass separately, brown glass collection, and then they pour it into the toilet. This is a black box. We don't know. It's going to be a calibration factor, but it must be significant. Then we have elimination and transformation in the wastewater treatment plant. Knowing about the effluent concentrations, we need to know the flow rate in the river. Typically, this is not modeled, but subject of measurement, and then we get the concentration in the river. And of course, knowing about our combined system, we have another bypass, and this is the combined sewer. So this is the layout we are using to structure and categorize what we are talking about. We are producing a flux model on what we see here, of course, not, as I said, on the flow rate in the river and of this part, how it comes into the system, how it comes to the consumer. So we go through it step by step. When we look at prediction, we received prediction information from the main health insurance for the people in Saxony. That's our province. Almost 50% of Saxon people are insured at the insurance company AOK plus, whatever it stands for. Well, it's 41 for the Dresden population. For the entire province population, as I said, it's around 50%. This is valid now for Dresden, and what you see here is, I think, 14 antibiotics, and it's just reported how the prescription of antibiotics developed over the years. And what you see is, first, which is quite positive, not such a terrible increase. It's even under proportional as compared to the population increase, which is quite okay. Then we see that some prescriptions are increasing. So amoxicillin is increasing slightly. But the yellow, the green, the blue, well, this must be a kind of detection error. It can't be that in 1 year you have only 1/3 and then it goes back up to what it was before. Most of them are rather stable or slightly declining. If you look at the green stuff here, cefuroxime, that's the only one that is significantly increasing to a manifold value of what was used a bit less than 10 years before the last year. We remembered cefuroxime. In the meanwhile, I didn't become a medical doctor, I didn't become a chemist, but I'm able to pronounce approximately these substances. So it's the input. It's the input into our model. So we must know, we must get an information about what is the input. Second part, excretion rate. Of course, we got some information here. We rely on our partners from the medical department, from the medicine department, and they say, you cannot say an excretion rate, but we need kind of a body metabolism efficiency in order to know of, how it proceeds within our flux model. It's depending on the application. It's of course antibiotic specific. For me, this was not a surprise. The body only partially uptakes the substance, and sometimes it's only a few percent. I was really surprised about this. I didn't expect this. And you have specific excretion rates. Most of it is excreted through the urine, but some also with the feces. So we got some information here. That was one of our project partner in the micro model project, and he gave us some information, for instance, about erythromycin, which is only up to 4% in urine, a bit more, 3 to 5 times, 6 times in the feces. other sulfametoxazole, which is an important antibiotic, to 15% in urine, so varying substantially, but still only a little. So 85% is not uptaken, is not used through the consumption. Interesting are the anti-epileptics, carbamazepine, gabapentin. Only 2% of carbamazepine, that became a very favorite tracer substance for water people through all the systems down to the groundwater, because it's inert and it's hydrophilic. So it remains dissolved and it is inert. So it's a rather good tracer substance, because it's also consumed very continuously and constantly around the year. There are no seasons where it is taken. So what now are the metabolites? So it's not all excreted. What about the rest? Is it really gone, or is it going to be metabolites that are even worse with regard to their effects in the water systems? We don't know exactly. We have more precise information because we had a project on antibiotics before, on the excretion rates of antibiotics. So all these is finding its way into our flux model, of course. We need desperately the excretion rates. So next step, sewage-borne compounds in the combined sewer system. So this is a very schematic layout of the sewer system. We have the urban surface, for instance, the combined system, the wastewater treatment, and then it's effluent into the river. We leave away the groundwater. We have the stormwater coming in, partially being overflown to the river system, partially being directed to the wastewater treatment plant. In France, up to 95%, I learned yesterday, which is extremely surprising. And also part of the sewage, because it's a combined system, will be discharged without treatment to the river. So we have the pharmaceuticals, especially the antibiotics, but also the resistance information about antibiotics that is introduced to the combined system. Then we know already somehow efficiency factors. So we know the overflow rate for sewage, which is surprisingly less well known than the overflow rate of stormwater into the river, because it was of no interest in the past, but it's becoming much more interesting in the future. The rest is entering wastewater treatment, and then it's reused, transformed, degraded in the wastewater treatment plant with a certain efficiency ether. And then you have the annual overflow rate of stormwater, which is a design factor in Germany, and actually it's more around 30% than only 5%. And we have a lot of retention tanks, so that's why I was asking. Very surprised this question yesterday. So people tend to say, why do you not realize a separate system where you bring all the sewage to the wastewater treatment plant, but on the other hand side, we then tend to forget that we deal with polycyclic aromatic hydrocarbons and heavy metals mainly discharged into the sewer system from urban surfaces. PAHs are subject to atmospheric deposition, so they're found everywhere, but a bit higher concentrated in cities, so we find them in the stormwater and in the separate system. 100% of these substances are directly discharged without any treatment, without any retention into the river. So what do you want, pharmaceuticals, or do you want PAH? Is that carcinogenic? Yeah? And on the priority substances list of the European Union, 8 different PAH compounds are listed, while so far only 3 pharmaceuticals, which will change in the next generations of these lists. So 100% is out. Then next step, looking at elimination of wastewater treatment. We did a literature study. We had some projects in the past where we looked at removal efficiencies. Of course, this is not really well done in the scientific respect, because we just were drawing columns here, but we need to add uncertainty. but then it would become very fuzzy. You don't see anything anymore. So you always have per substance, you have, now here's something went wrong. Everything else is perfect so far, but yeah, left and right is exchange. Yes. If you have a mirror, bring it with you and you will understand. Substance-wise, you have three columns. The first one, the black one, is conventional treatment, so primary treatment, biological treatment. The second one, the light gray one, is plus ozonation, and the anthracite one is plus activated carbon filtration. And what you see is, yes, you are going to improve the performance of your wastewater treatment plant with regard to the removal of priority substances significantly, but you're not solving the problem. Those columns do not reach the sea. We are not at 100%. So we're still releasing something, of which we must somehow evaluate what does it mean if you release maybe only 1/3 of the substances to the river. If the effect is there and can be proven, maybe the effect is still there if you reduce it to 1/3 of the original load. Most problematic are the X-ray contrast agents. There are, even with tertiary treatment, they are not so well degraded, not so well eliminated, not so well transformed. We have the painkillers, where we have significant differences in the conventional treatment. So whenever I go to the pharmacy and need a painkiller, I tell them I want ibuprofen because it's much better degradable than diclofenac, for instance. Maybe you have different substances here, so I'm not allowed to mention the names of the effective substances. So that's about where we want to go, 80–90%. I mean, Switzerland has made a political decision to introduce a tertiary treatment for all treatment plants above a certain size, and also for a dilution ratio downstream of the wastewater treatment plant below a certain threshold value. And they were calculating for the flux model with a general efficiency of 80% and sometimes 90%. Not 100%, not 95%. But however, now still the question is open about the transformation products. We have an efficiency here between 80 and 90% for this substance here, which is Primipol? No, I don't know. It's double turned. Okay, you make your own interpretation.
You'll find your version.
It's 90%, but we don't know what happens with these 90%. Yeah? The mother substance has gone, yes, to a large extent, but we might have produced 5 transformation products whose effect might be even worse on the aquatic ecosystem. So then we can do something just to try to predict the destiny, the fate of this pollutant with just our knowledge we have. Just be serious and you can kind of classify the behavior you expect. You have to distinguish between degradable and non-degradable substances and between hydrophilic and hydrophobic substances, assuming that the hydrophobic substances are going to be absorbed at surfaces of particulate compounds. And just using this very simple 2x2 matrix. Of course, many substances are around here in the fuzzy region are not so clear to categorize, but just with this distinction, you can have a good expectation on where you expect these substances. So we need just this a priori information. The main descriptor is actually whether these substances are degradable or non-degradable. So the dissolved, non-degradable ones are the substances we find with a high priority in the wastewater treatment plant effluent. Now they're going to sustain. The other ones, non-degradable and more adsorbed to particulate surfaces, we find them in the grit chamber, we find them in the sewer sediments. They might be flushed away with the first flush effect from the sewer system over the combined sewer overflows into the river. So you find them in the riverbed, but you also find them ultimately in the sludge. So we also were carrying out quite some measuring campaigns. What you see here is a very simple sketch from the antibiotics project. We were distinguishing between ambulant prescriptions and stationary prescriptions done in hospital, where we know that these substances are only prescribed in hospitals for patients who are resident in the hospital and who consume and excrete these substances in the hospital. So what you find here is always a hit list of the substances with the highest prescription, then with the highest concentrations in the dissolved phase in the sewer. These are the hospital prescriptions, and we were able to measure at the outlet of the hospital area, which is quite the largest hospital of the city of Dresden. And then we were following the hit list, just the 3 most often detected substances. So in the wastewater treatment plant inflow, we already find cefuroxime. You remembered cefuroxime, with the highest concentration in the inlet. Clarithromycin, clindamycin is actually a dentist's antibiotics, also the tracer because it's regularly consumed over the year by the patients. And this is the wastewater treatment plant effluent. Cefuroxime being the highest concentrated, clindamycin the dentist antibiotics, and its main transformation product being second, and clarithromycin being third. If you look at clindamycin SO, same concentration in the inlet as in the outlet, so nothing happens. Non-degradable. Cefuroxime is reduced by a factor of 2.5, reduced to 40% at least. But still, we have the highest concentrations here. This is most relevant from the environmental point of view. And this is exactly the substance, the only substance of all the antibiotics whose prescription rate is significantly increased over the last years. We must come into the situation from the legal point of view to ask for degradability information of these substances before they are allowed to be released. So then if we go to the adsorbing substances, we find these hit lists in the sewer sediments, similar ones in the grit chamber, and ultimately also in the sludge. So, dynamics. Dangerous, it's a hobby of mine, but I will be short on this. Again, we have the same system as before, just to focus or state the main information or the main differences that the outlet, the effluent from the wastewater treatment plant is a continuous impact to the receiving water, whereas the combined sewer overflow is intermittent. It only happens a few times per year. In Germany, I would say 10 to 20 times. Belgium, I know of the regulation, they have an allowed number of 7 overflows per year. Here it's 4 per year. Tough. Very tough. Okay. My greatest appreciation, but do you monitor it on all the thousands of overflows? Yeah, okay, interesting. Whatever, it's intermittent, only a few overflows per year. Yeah? So, when we look at dynamic effects, this is a monitoring site we could build up in the last years. We call it Urban Observatory, where we have measuring stations in a small subcatchment of the city of Dresden, associated to a relatively small river, Lockwitzbach. Lockwitzbach will become famous sooner or later. We have online measurement stations where all the online sensors that work more or less in sewers or in wastewater, we have installed them there. Additionally, we do sampling, and these measuring stations are installed in a separate system, in a combined system, in front of the overflows or discharge points to the river. And then we also have 2 measurement stations upstream of these overflows, downstream of these overflows or upstream of the confluence with the river Elbe, which is the main collector river. And what we see here, the green lines are the downstream measurement station and the red lines are the upstream measurement stations. This is a heavy rain event, and what we see in the river, downstream in the river, and it must be originating from the city because upstream of the city's influence you don't see the peak that high, both for the loads and for the concentrations of NH4 plus, of ammonium, and you see heavy peaks in the loads and even in the concentrations in the river. So you have this push-out effect of the concentrated sewage that was in the sewer system before the rain event started with a higher velocity. So you can show it with the Saint-Venant equations that there is this dynamic effect and you do not have an immediate dilution of what is in the sewer before the rain event starts. You push it out as concentrated as it is. You're not going to increase the concentration in the sewer system, but if you produce a combined sewer overflow to the river, you're going to increase the concentration in the river substantially. So this is inducing an acute impact, not an intermittent impact. What do these peaks mean? First, ammonium, it's a boring substance. We know it's in stechates. Why ammonium? It's because ammonium is to 85% of what we find in ammonia, in terms of ammonium in the sewer system, 85% approximately is introduced through the urine. And so are most of the pharmaceuticals. So it's a good tracer substance and much easier to measure for pharmaceuticals also. So we expect that at least the relative variations, the variability is very similar between pharmaceuticals and ammonia. That's why it's still an interesting substance. And just as an example, we could also measure in the sewer system shown here over a period of 80 hours. This is a dry weather day with the flow rate here. We have a slight rain event here and there, and this is producing of one of the antibiotics we were looking at, azithromycin. It was producing a significant peak. This peak is sent towards the treatment plant on the one hand side, but also through the combined sewer overflow into the receiving. That there are no standardized ecotoxicology tests about these short-term effects. These tests are designed such that organisms are exposed to some concentrations for a relatively long time, but not to short peak concentrations. You don't have a good information about the impact into the ecosystem of the river. So what is the significance of these peak impacts? This is the question. Now I come, after the layout of everything we knew, to the compounds flux modeling. We know the model. I don't have to describe this anymore. It's still animated. Animation also works. Okay. Now, we are focusing a bit more on these two bypasses, which I mentioned, which I introduced before. It's a pathway we have to consider. We can, of course, kind of check our model by doing measurements in the sewer system, in the influent and effluent of the wastewater treatment plant, and also in the river system. Now, looking or assuming a substance that is consumed, when you compare it with the prescribed amount of the pharmaceuticals, it's consumed by 95%, it's disposed by 5% to the toilet. That's the first assumption. Then we have an excretion rate of 2%. It happens. We have these substances. Then the transport in the sewer is conservative because it's an inert substance. We have an annual overflow rate of combined water of approximately 5%. Not of combined water, actually. What I wanted to say here is of sewage through these intermittent events. And the last assumption is with the tertiary treatment, or let it be ozonation, we have a treatment efficiency of 97%, so only find 3% in the effluent. Under these assumptions, we can just attach numbers to all the arrows here, and it becomes obvious that all of a sudden, with a low excretion rate, with a good treatment plant efficiency, all of a sudden, the direct disposal and the combined sewer overflow become very significant, comparably very significant, if not dominant. And these are two things we tend to forget. And this is now significant, even neglecting the acute effect of impact peaks. Even on the annual load basis, it may become dominant. So we put together our flux model. That's the first test run, just to show what happens in the river Elbe with regard to the sum of all antibiotics we were following. And this is what you see here. We were defining a risk index on our own that was very much criticized, but however you can criticize it, but it's the best we could do. Right? There's no alternative. There's no official risk index for the medicals or for the pharmaceuticals you're introducing. We were just comparing the PEC with the PNEC value of each substance, and we were summing up these factors. You can criticize it, yes, we criticized it ourselves, we are not very happy with it, but this is what happens. And if you look at the sum, we are in a critical range, even with a relatively strong receiving water with a high self-purification and a high dilution capacity. And what we were surprised about is that in summer terms you have lower, in summer terms you find the peaks. In late summer you always find the peaks. And this is not due to higher pharmaceuticals consumption in late summer, it's due to typically low flow rate in the river. So dilution matters. So now, which is more interesting, we went into spatially resolved information which was used. First, we were doing kind of an overview of what is measured anyway by the state. The state is measuring a lot, and they provide all information publicly on the internet, so we could work with the data. So all these points for Saxony, they are measuring points in rivers, might be water level, might be quality measurements, but it's all based on sampling, and the sampling is done every 2 weeks to every half a year. But with 150 substances, we were completely flattened. So I would think we could significantly improve the information, measuring 50 instead of 150 substances, but doing more. So the flow rate is measured at 216 measurement points, important information, and it's done on a daily basis. So this is the resolution we could get with the prescription information. This was important. We expected an even better resolution, but we could not do it because of the people's protection, data protection issues. You have to be careful. When you have a prescription region with 2 prescriptions per week, then theoretically you would be able to identify backwards who did consume which medical. So we were not allowed at all to do it. But however, even in the agglomerated form, we had a good spatial resolution, which is very unusual. We didn't find a study with a comparable resolution in space. Then we were focusing on, because these 3 wastewater treatment plants, they were partner in the project, on 3 treatment plants with different characteristics in terms of the mixing ratio of the treatment plant effluent and the river. Here, the river Chemnitz is a very weak river. The annual average low flow rate is less than a cubic meter per second, and Chemnitz is close to 300,000 population equivalents. Dresden has a low flow rate in the river of more than 100 cubic meters per second, so we are much better off, even though the size of the city is around double or a bit more than double. And Plauen is somewhere in between, the smallest city, and you have an annual low flow of typically a bit less than 2 cubic meters. So we had 3 different cases, We were looking at scenarios, the present condition, of course, as a reference. Then we were looking at the extension or the improvement of wastewater treatment plants with more than 50,000 population equivalents. We were looking as an alternative to other criteria for the extension of wastewater treatment plants. One is if the treatment plant is delivering 50% or more to the river flow at low flow conditions in the river, then where the concentration according to the environmental quality standard is exceeding under low flow conditions, so it doesn't mean all the time, under low flow conditions, more than twice. We are extending all these. Then we are looking here at carbamazepine, the anti-epileptic drug I was mentioning. We were looking at the replacement by 50%, so we reduce the input by 50%, or we deconnect the hospitals, assuming they have an own wastewater treatment plant. And then we were evaluating it with two criteria. One is we wanted to reduce the, I start with the lower one, reduce the load at the outflow of the considered catchment, or we wanted to reduce, as far as possible, the accumulated number of river kilometers. And then we had the three test cases. First, here is Weiße Elster, that's the Plauen catchment, the smallest city with a medium self-resilient or self-purifying river. We can go through, oh, what's the wrong button, sorry. We are back here, we could go through all the numbers. I don't think you would like it, but we can conclude from that, if you just look at, here we have the kilometers of the rivers in a bad state, in a critical state, and in an acceptable state. And this is the reference. And when the numbers here increase, it means we have more river kilometers in a good state. So when we compare the scenarios with extending the treatment plants, what we get is here not really significant improvement, but we reduce, when we just look at the percentage value, we significantly reduce the load at the effluent of the catchment. So what do we want? It depends on our goal. Do we want to reduce the number of kilometers in a bad state? That might concern small rivers before the confluence to the larger cities and so on. Then substitution is a much better idea. You get most of the kilometers into a better state. Or you look at small treatment plants that are located at small rivers, which are critically loaded. The same applies now, or similarly it applies for Chemnitz. Here you have, with extending the wastewater treatment plants, inducing critical conditions in the river, you have a good reduction of the critically loaded river kilometers. In terms even of the load reduction, you are most efficient here. So it's not only dependent on the criteria you apply for your goal, it's also dependent on the characteristics of the catchment. So it's not so easy to tell we have, I don't know, 20 million, how do we invest it best? We have to politically discuss in the society what is our goal and when are we more satisfied. And for Dresden, I mean, what you see here, if you improve the best, the three large treatment plants, what you get is a reduction at the outlet of the state of Saxony by 1/3, but you're improving 3 kilometers. With regard to that, it's not interesting. With regard to this, it might be interesting. And also the substitution is reducing or increasing the river kilometers in a good state most significantly. and is reducing also the load substantially. So we must discuss the options. It's not that basically only additional treatment is a good option. Right? There might be a more efficient option, but it is dependent on the system, it's dependent on the ecosystem. So we should not discuss whether or not we should imply tertiary treatment, we should discuss where and under what circumstances. So I come to the challenges. That's actually the final chapter. I have 2 huge research chapters which I throw out throughout of the presentation if you are interested. What's the significance of hospitals? People tend to say, so what about hospitals? Their contribution is in the region of 10 to 20% to the total pharmaceuticals because people are consuming them at home. Very simply, consuming them at home. So the conclusion typically is we don't do separate treatment. This is not worthwhile doing it. But when it comes to certain substances, for instance, the so-called secondary antibiotics, they reserve antibiotics, they are not applied in the ambulant mode because you don't want to distribute the resistance information to a far extent. So they are only applied for stationary patients in the hospitals. And with regard to that, it's certainly worthwhile thinking about better solutions than just to distribute it through the wastewater treatment plant, the public communal wastewater treatment plant to the environment. Well, let the people go to separate toilets, for instance, or let them wear some undertrousers to collect the water, whatever. Yeah, but this is more efficient. Might be other risky compounds. Then, next, just to look at the options we have. We can go for treatment of combined sewer overflow in order to reduce these peaks. We can try, and this is a completely different field of knowledge, to provide people with better information that they do not dispose any non-consumed pharmaceutical substances directly into the toilet. Sounds very banal, might be very efficient, depending on the conditions. The river could be improved with regard to its resilience. Looking at the ecosystem services might be an interesting subject. Then when we look at wastewater treatment plant, this is what engineers typically spontaneously see as the most promising improvement potential, improving the processes, of course, but it could also be improving the conventional processes with regard to the elimination of these priority substances. Then, looking at the pharmaceuticals as such, why not trying to have difficult pharmaceuticals designs with new criteria? Medically, they must provide the same efficiency, no doubt. We do not want to touch this. But through kind of changing something else, external groups, their biodegradability might improve without losing any medical effects. This is possible. There are some good examples about this. There are patients about this, but there are only few. I mean, the research in pharmaceuticals design is not going into that direction at all so far. This takes time, yes, but it should be done and initiated now. Then the prescription. We are heavily interacting with the medical doctors. We are organizing educations, we are organizing seminars, we are organizing workshops together with them. They prove to be very interested in that. But this is a potential to reduce prescription where it is not absolutely necessary. We observe that many antibiotics are prescribed where you do not have a real medical indication. People are sneezing a bit, there they get their antibiotics. The sneezing is because of viruses and you can only act against bacteria with the antibiotics, so there's no reason to do this. It's just the provisionary medication that nothing else happens afterwards. Not a good idea. And just to show you, final slide, that there is a potential in this. That's the population-specific prescription rates in Germany on antibiotics. And if you compare Eastern and Western Germany, Eastern Germany seems to be much better. So in the average, antibiotics prescriptions in Eastern Germany are only at about 2/3 of those in Western Germany. So there is a potential. And I don't think our health is worse in Eastern Germany than the health of the people in Western Germany. I do not only not think so, I'm quite sure that this is the case. So there is a potential. These are official numbers. And if you compare, there are really studies done on this in entire Europe about antibiotics, population-specific antibiotics prescriptions. Scandinavian are, as quite often, the best. And then if you go south, southeast, it is increasing substantially. Germany is not bad, but also not among the best. If you only look at Eastern Germany, it's relatively good. So that was it. Final slide. That was a picture in a kind of popular science journal. We got, you might not see it very well, it's in the sewer system. The photographer was insisting to have a picture of the two of us. Next to myself, it's Thomas Behrendonck. He's the hydrobiologist, an evolutionary biologist, very much interested in antibiotics resistance, development and spread. And they insisted to photograph us to take a picture in the sewer system. I told them it's not very convincing. Then we changed it and we told to the people this is our daily work. And surprisingly, the photographer came in to take a picture during our daily work, and only afterwards we realized that it happened. So thank you very much for listening to us, and also look at the funders, at the projects that came into this presentation, and most important, the people of my group who were contributing to that. Thank you very much.
People have to run, but if you have some time.
I'm sorry for doing overtime.
Yes, sir.
Floor is yours. Can you look? We're just checking where this. There's also questions online. If you want to have a question, you can just write it down in the chat box. There's one? I don't see. Oh, there it is. So I'm going to start with that one. Is the pharma's proportion from hospitals considering also some other health centers, like old people centers, or is it separate?
As far as I know, this is only hospitals. But it's an important question that the elderly people's home, that they are a source where the medication is much higher specifically than in other points. From my viewpoint, it's even more worthwhile to look at those centers than at hospitals. But it apparently is more difficult to have separate treatment for those because they are spread over the cities, whereas hospitals are more organized in centers, so it's easier to have an efficient, decentralized wastewater treatment plant.
Good question.
So you're talking about hospitals, but pharmaceutical manufacturing plants, do you have any idea about how pollutants get discharged there? Because they also rinse, they also clean their production equipment. Is there like a big percentage that comes from pharmaceutical manufacturing?
Just to let you know that Niels worked for a pharmaceutical company.
No.
Pharmaceutical manufacturing.
Well, then you might know it's extremely difficult to get information and data from the pharma industry. My impression, but this is gut's feeling more than an impression, is that they are working rather clean. So whatever is worthwhile recycling, they do so, because it's an economic factor. So I do not expect that their impact is more significant than the impact of the distributed consumers or of the hospitals.
You have to repeat the question, otherwise people in the audience. Next time you repeat the question for people to know.
Sorry. Yeah.
Is there any regulation that pharmaceutical companies follows in the wastewater? specific regulations only for the pharmaceutical companies because they have high concentrations of
Well, the question is about regulations for pharmaceutical companies for the introducing their wastewater into the public system, I guess. Basically, yes, these regulations exist. They are not so well developed for those priority substances. They are well developed for all the, I would name them classical wastewater ingredients, such as COD and the nutrients. But this is going to be managed more and more in that direction. So you have threshold values for the wastewater treatment plant effluents, but you also have threshold values for introducing your wastewater into the public system. However, it's relatively difficult to monitor. So the way it's done in Germany is they have non-announced sampling campaigns, and 4 out of 5 samples must fulfill the threshold value. But the industry does not know when the people are sampling.
Now we have, let's say, environmental engineers. We see this issue that drugs can be persistent in the receiving water. Did you ever have the chance to talk to pharmaceutical people more? Because I don't know, I have to say I don't have a lot of experience in it. And then I was wondering, don't they say, oh my God, another factor to consider, and we really have already enough, because pharmaceutical legislation, as far as I know, is anyway so complex to get those drugs passed that they say now if we even have to care for the environment, we cannot develop any drugs anymore. Or what are the typical reaction, let's say, when if you had the chance to talk to pharmaceutical people, how would they react to this suggestion of considering the environment?
So the question is about the reaction and the readiness of the people from the pharma industry to adapt to these new suggestions about having new pharmaceuticals design that is environmentally friendly. You have some prejudice. The good and the bad, and the pharma industry, they are the bad. It's not true. To my experience, to all the people I was able to talk from the pharma industry, they were quite relaxed and they were ready to take this challenge. And well, if you give us the money, we are taking care of it. They want to have covered their costs. Yes, that's their condition. But I must say, of course, the sample of people with whom we could talk is maybe not representative for the pharma industry, because these were the people coming to our events, so they are interested in the subject. There must be other people who are probably not ready to do so. But basically, this is a good reason. It's economy, and as long as they have covered their costs, they are ready to go into new developments.
I'll take another question from the people elsewhere. Do you know any sources of information regarding PTCP, so the pharmaceutical and personal care products, for drinking water? Is that information available, or is it difficult to get?
It's difficult to get. I don't know of any good databases about this, because it's a much more delicate subject. No, it's directly our health. But there are some studies about compounds that were found in the drinking water, and then it pops in the media, and it's an intense discussion for 2 weeks, and then it disappears. And then balances were made taking as a reference the concentrations in the body, which are the threshold concentrations. And it turned out that you would have to drink for 2,000 years 2 liters per day of tap water, and then you would reach this threshold concentration. So the fact that those substances are present in the drinking water and can be detected with the best chemical analysis method does not automatically mean that it's going to be risky or even dangerous for us.
You mentioned that Switzerland decided to introduce systematically tertiary treatment water treatment. On what did they base their decision? On a model like the one you have done, or of a consideration?
That's a very amazing process that took
Can you
place in
repeat the question?
Switzerland.
Repeat the question.
It's the question about Switzerland. On what basis did they take the decision that they want to expand and improve their treatment with tertiary treatment, but particularly either ozonation or activated carbon adsorption in order to reduce priority
And the cost
substances?
is about 100 billion, right?
Something like this.
Euros.
Two things were amazing. First, the decision was taken on the basis of a flux model. But our flux model is much better.
But would you have the same conclusion?
No, yes and no. We have a very diverse conclusion. We are raising more questions than taking the decision. Second amazing effect was it is based on a people's vote. It's a public vote, as it is the case normally in Switzerland. So it's Switzerland-wide, all the people allowed to vote made a positive vote for being ready to invest this money into the extension. Now, all the European countries, the neighboring countries, they are a little bit afraid of this decision. Do we have to do this too? But yes, but everybody is actually grateful for this large-scale experiment carried out in Switzerland, and they now observe from distance what happens and
how far are they now? Because they go with the biggest first, I think. Are they?
They are starting with the largest ones.
I remember your presentation.
I think they have about 10 plants in operation now, and many more are to come within the next 2 years, 2020.
What about the persistent metabolic products? We have looked to the initial pharmaceutical molecules, but what is the fate of the metabolic residue in water and how it's impacting the rivers, the quality of the river's water?
Does it? Question was about the metabolites and their effects to the river ecosystem. We don't know a lot about metabolites. Of some substances, we know that 5 to 10 metabolites are produced, and we even know that some of those 5 to 10 metabolites are worse than the original substance. But to quantify this is extremely difficult. What do we want to chemically analyze? You are a chemist, I think you were sitting next to it. You like to analyze thousands of substances, but it can not be operated out there in the real world. We need to know this in university and research projects. We need to know the mechanisms, but later on we have to aggregate. We have to simplify the procedure. So what we initiated, and these are the overheads I was throwing out from the presentation, we were looking at effect-based analysis. So we are looking at ecotoxicological effects without exactly knowing all the individual substances.
Whole effluent toxicity, for instance.
Yeah.
Whole effluent toxicity.
And according to your answer, do you have the impression that with this lack of information, that it's not biasing your flux model information according to the impact on the river, and how we have to consider this information for the management of the environment?
So the comment is that the flux model may be questioned because we do not consider transformation products, the metabolites so far. Yes, this is true, but in the flux model, we do not say anything about the receiving water quality, which is given information about the concentrations we find in the river. The more we know about metabolites, the more of this information we can introduce to the flux model. But apparently the knowledge about metabolites and transformation products is not so good anymore. Yeah, it's just too much. I may add an information with regard to this effect-based monitoring. What we could detect is that if we manage to substantially reduce, and this was done in pilot scale wastewater treatment plant, a bit smaller than yours in the cellar, only slightly smaller than yours in the cellar, and we added tertiary treatment, with and without tertiary treatment, and then we looked at the ecotox effects. And reduction of the ecotox effects were by no means linear to the reduction of the original substances. So there is it's generally not a linear correlation, but it's much more complex than this because you produce a new mixture of substances.
Thanks.
You were talking about the education to reduce the direct exposure of pharmaceuticals. I was wondering, do we have plenty of infrastructure to treat correctly this pharmaceuticals that we will bring, I guess, somewhere else instead of disposing?
How can we act with education to have a better flux balance at the end? This was kind of the summary of the question. Education is an option in two respects. Informing the public is one. We also had some trials to have information of the public where we could see an effect, not with regard to pharmaceuticals concentrations, but with regard to these solid papers, the wipes, which are used and which are difficult for all the pumps and so on. They were reduced in the Dresden wastewater for about 1 year significantly, and then it went up. That's how it is. And another thing is the interface to the medical doctors. And I was asking, and I will be able to go into their bachelor education and give at least 2 double hours or something, a presentation like this, to make them aware of the fact that everything they prescribe we find in the environment at last. This is something which must come into the heads of the medical doctors. You cannot put it into the medical doctors of my age, but let's try it in the study courses. It's all.
In Belgium, at least, people can bring in products that expired. They can bring them back to the pharmacist. But people don't know that they can do that. But you can bring expired products to the pharmacist.
People know, but often people don't care or don't think about it.
So the system of taking back pharmaceuticals by the pharmacies is an important system. But however, what they do is, at the end, incineration.
No, they don't throw it in the toilet.
I hope so. Not that I knew. Actually, they have a separate incineration of special waste. So when your waste is ending in the incineration plant, you just do it to the Restmüll, to the non-special.
Okay, yeah.
So that would be also the correct way of disposal at home. No, there's no difference to what the pharmacy does by the end. If you have a dump site, then of course it should be the return system that should be used with the pharmacies. But anyway, it doesn't belong to the toilet. Yeah.
I like the unannounced measurements. I just brought back my memories from my undergrad studies when I used to measure heavy metal contamination in rivers during the day and at night. It was always several orders of magnitude higher at night because the steel industry didn't like to see us out in the field and measure the concentrations. And the other critical comment may be the pharmaceutical giants are sitting in Basel, and downstream from Basel there have been fish kill events in the Rhine River, major fish kill events, and I just wanted to know if pharmaceutical companies are obliged to do what's called Rückstandsanalytik, so to what is accumulating in livers of organisms, aquatic organisms, fish, and down the food chain to the very bottom, to monitor what is going downstream to France, Germany, the Netherlands. I think Switzerland was a little bit pushed by other countries to do something and make efforts to avoid such major fish kill events. And so my question again is, what is being done to monitor what's being flushed downstream?
Well, how is it monitored, or is there any monitoring of the effect? Just repeating the question for the online people. Is there any monitoring of bioaccumulation in organisms of these priority substances downstream of heavy industrialized pharma industry? Not that I knew. This would be an extremely important approach. I agree very much. What they have to really deliver is concentration values, and they have to fulfill effluent. The pharma industry, and you were addressing the Basel pharma industry, where there is a heavy center. They have their own really advanced wastewater treatment plant. So because they're quite compact, different production sites of the pharma industry in Basel, so they have developed their own wastewater treatment plants. But internally, they had problems, very simple problems, as I said. Because I have an old friend who was in the environment department of one of those of the pharma industry production sites, and they were trying for 2 years to take out a certain critical substance. They were not able to do so. And once in the evening, he walked through a production hall and he was realizing how these substances come into the wastewater. At the end, the hall was just cleaned with the water and it was down the drain. And he said, don't clean it with the water, collect it in the dry mode and bring it to the incineration plant. And it was done and the problem was solved. This is not representative for all the problems you have there, but this is also something quite trivial which should be checked. How does the substance come into the chemical wastewater effluent? But your approach of looking at accumulation, at bioaccumulation, would be a very important approach. No, so far not.
I have one more question. Is there numbers on the 10 to 20% hospital release? Is that published, the information? You mentioned 10 to 20% of
that's not done by ourselves. Okay. We got it from the literature, but I presently cannot recall where from. Various.
If you still listen to us, I can forward the question and then we'll organize. We'll find out. Last question, Niels. I think we're. No.
So you mentioned something interesting that you said ibuprofen. I prefer that because it degrades better than ibuprofen. But do you think patients would give other patients would give value to this impact? If, for example, your pharmaceutical would have an environmental impact score, would they prefer one drug over another? Is there any information on this?
No, it's not.
Change their therapy based on their environmental impact?
It's over the counter, right? This is over the counter medication, right?
So the question is, could we have a steering or controlling effect on the selection of pharmaceuticals towards better biodegradable pharmaceuticals by informing the consumers? I believe in this. Yes, it's not 100%, but if the product must tell something like a standard degradation experiment, it's degradable to a certain extent and they give a percentage value, it has to be on the box. I'm pretty positive that consumers, if they get the same medical effect, would choose for the better degradable substance.
But even though you cannot change the prescription because some drugs have side effects, right?
Sure.
Yes. Yes.
Because it should not be done over the counter, it should be done with the
but many the over the counter versus prescription is a very big discussion.
Yeah. So the comment was that, of course, the medical effect should be guaranteed. And this is only the case if they are equivalent. If you look at, but we discussed it with medical doctors, if you look at ibuprofen and diclofenac, it's about 80 to 90% overlapping, where you can prescribe them both. 10 to 20% you need to prescribe diclofenac, because then ibuprofen cannot substitute it for specific treatment.
And it's an add-on?
a very small question. So you're talking mainly about small molecules, small pharmaceuticals. But now the trend in the pharmaceutical industry is towards large biopharmaceuticals, because there's these small molecules. All of them have been known, have been around, but new therapies are more biopharmaceuticals. Do they have an impact on our environment? Is there any information on how large pharmaceuticals, such as proteins, viruses, these kind of things, result in our environment? What is their impact, or are they not considered because they are easily degraded by the environment?
I'm not sure. It's about new type of products, larger molecules, biomedicine, like viruses and things like this. I don't have any information yet about this. This is a subject to come, certainly. Larger molecules, larger whatever, let's call them biopollutants, bioparticles, are easier to remove. Then it certainly goes towards the membrane treatment. And if you don't have the membrane treatment in the sludge process, it's more efficient to run the additional tertiary membrane treatment because you do not have clogging every other week.
Ryan had the last word.
Okay.
In the study, you followed the more relevant pharmaceutical products that you could find in the wastewater. So, do you think that it would be good also to look into pharmaceutical products that causes more toxicity to the river and to the aquatic system more, because they, for example, for pharmaceutical products, they have more toxicity even in small, very small concentration. So, do you think that it would be also good to follow this, like these pharmaceutical products, and if you do have access to, like, if it does exist, a database showing a comparison between the toxicity of these products?
So the question is about the toxicity and, well, whether it should not be reflected, because I was not talking about toxicity. Actually, when you talk about the importance and the risk of substances, I was having this 2x2 matrix. You should have a third axis, and this is toxicity. Relevance, risk relevance of the material. Yes, this matters a lot. And that's what we did with our risk index, where we compared the PEC with the PNEC value. That's somehow the PNEC value is considering toxicity. But it is enormously important, of course. So new products should be more and more biodegradable, and they should be less and less toxic to environmental substances.
Can I make the link to the REACH approach in Europe, where they have to evaluate every chemical for its production? I know there's a kind of limit that below a certain production you don't have to go through the procedure. Yeah. Are pharmaceuticals below that limit, and therefore they don't do the biodegradability tests that they have to report normally?
I do not have good information yet about this, but some of the pharmaceuticals, they are below this threshold value. It's about chemical industry, and they are producing much larger masses than pharmaceuticals.
Because it would be nice if they would be obliged to provide them the information that's there and they could use it.
And also, what we did not do, I did not talk about agricultural pharmaceuticals. Next to come.
Are we satisfied with the answers and questioning and the presentation? I think it was very useful. So the presentation will be sent around, will be available through the CentrEau website. You'll be able to download it. That's allowed, which I think is.
I agreed.
And I would like to have all of you give a hand to Peter for a very nice presentation.
And again,